Okay, so in this video we're going to have a look at 6 of the hardest quadratic inequality questions. Now we're going to have some questions where we are going to have to just solve them, and we're going to have some questions where we're going to have to form and solve a quadratic inequality, and also some of the ones where we're going to have to apply a few different bits of mathematics towards them. And these are in no particular order of difficulty, but we are going to kickstart with one of the easier ones, just to give you a little hint of how difficult some of these questions are going to be. And again, these are quite high level questions, so make sure you've got a piece of paper, you've got a pen, you're making some notes, and we're going to kickstart with this question. So for this one here, we've got to solve this inequality. Now to start with, we've got a bracket on the left there that's being squared. So before we do anything else, we're going to want to expand that and just make sure that we show what that is once it's expanded. So obviously if that's being squared, that's a double bracket. So if we just write that as a double bracket, we've got 1 minus x and another 1 minus x. There we go. And obviously, just very briefly, throughout this video, I'm going to assume that you have a good knowledge of quadratic inequalities, so do check that out in the description below. That video is going to be there on quadratic inequalities, but we are going to be looking at, pretty much just difficult questions like these. So I'm going to assume a bit of knowledge when we're doing this, just things like expanding double brackets and factorising and all that sort of stuff. Okay, so if that's a little bit too quick for you, obviously do go check out those videos first. So when we expand this, we get 1 times 1 is 1. We've got minus x, which is minus 2x, and negative x times negative x is plus x squared. There we go. Now I want to write that here again, because I'm going to put it back into this inequality. I'm going to rearrange it, so I'm going to write that x squared first. So we've got x squared minus 2x plus the 1 at the start, as that's positive 1, is less than 9 over 25. Now what I'm going to do is I'm going to remove this fraction on the right. So I'm going to times both sides by 25. Okay, there are other ways of doing this question, but I'm just going to do this question this one particular way. So I'm going to remove the fraction, times them by 25. So if we times everything over here by 25, we get 25x squared minus 2 times 25 is 50, so 50x. 1 times 25 is 25, so plus 25, and that is now less than 9. Now we want that to be 0 on that right hand side there. So let's make it a 0 by minusing 9 from both sides. So when we do that, we get 25x squared minus 50x. And then we've got 25, take away 9, which is 16. So plus 16, there we are. And that is less than 0. Right, okay, so one thing that you want to have a look at is a little quick check. Is there a way of simplifying this? Can we divide everything by something? So we've got 25, let's just highlight these. We've got 25, 50 and 16. They're not all even, so we can't divide by 2, can't divide them by 3 or 4 or 5 because they're the 16. So no, we can't simplify it, so we're going to have to factorise from there. So let's go about factorising this then. Now as we've got a 25x squared, we're going to want 5x in each bracket. So let's do this up here. We've got 5x. And another 5x. There we go, and let's have a look at some of our factors. So we can have 4 and 4, or we could have 2 and 8, or we could have 1 and 16. Now obviously both of these factors in this case, if I go for 5 and 5 in my bracket, both of these are going to be multiplied by 5. So instead of looking at it as 4 and 4, we could look at that as 20 and 20. That's not going to make minus 50 in the middle, so that's not going to work. Moving on to the 2 and the 8, let's have a think. We could have 2 times 5 is 10 and 8 times 5 is 40. Now there we go, so that combination is going to work there. Okay, as our factors are going to be doubled, so that number, rather than being 2, not doubled, to multiply by 5, so rather than being 2 it will be 10, and rather than being 8 it will be 40, and we can definitely make negative 50 out of that. Now we've got a positive 16 at the end, so they both have to be negative in order to make negative 50. So we want minus 2 and minus 8. There you are, and you can always go ahead and actually expand that and just double check that it does actually create that quadratic there that we've got. So we've got our two solutions that we can get from here. So we've got x is equal to positive 2 over 5, and we've also got that x is equal to positive 8 over 5. There we go. Right, so 8 over 5 obviously being our larger value there, and 2 over 5 being our smaller value. Now, in terms of actually writing this solution, as it is a quadratic inequality, we need to write our inequality solution. Okay, so for less than, we are obviously looking at, and this is all related to a quadratic curve. This is going to be, let's have a look, both of our solutions there are positive, so our quadratic would look something like this. And we're looking at the bit that's less than 0, so below the x-axis there, so it's between 2 points. And when it's between 2 points, we write our solution as an inequality like this. There we go. And we put the smaller value on the left, 2/5, and the large value on the right, 8/5. There we go, so our solution there can be anywhere between 2/5 and 8/5, okay? Not inclusive, obviously we've not got the equal to symbol on our inequality there. So that's our final answer. X has got to be between 2/5 and 8/5, and that's how we write our answer. There we go, there's our first question. Let's have a look at our next one. Okay, so this question here says the region R, which is shown in our diagram, is the region between two circles with the same centre. And on our diagram over here, we've got that the radius of the small circle is n minus 1, and the radius of the large circle is 2n plus 6. It then says the area of R is greater than the area of a circle with radius n plus 13, which isn't given to us in the diagram, but it's just a separate circle. And that's our hint there that we're going to be using an inequality. It says the area of R is greater than the area of this other circle. It says n is an integer, so a whole number, find the least possible value of n. Now, and obviously to do this, we need to find out what the area of that shaded region is, because the area of that region is greater than the area of this other circle. Now, in order to do this, we need to know the formula for the area of a circle, and that is pi r squared. Okay, area equals pi r squared. So in order to work these out, we need to actually square these radiuses. So we've got this one here, we've got n plus 13, and we need to square that. And we could actually look at these other ones over here and look at the shaded region to start with, but we've got a lot of areas to work out, so we'll just start with this one over here. So n plus 13 squared is n plus 13 and another n plus 13. There we go. And if we work that out and expand that, we get n squared plus 13n plus 13n, so that's plus 26n. There we go, and plus 13 times 13 is 169. So there we go, that is our area for that circle. Now technically we should put pi with that, so if I just put that in a bracket and I stick pi with it, there we go, I'll stick it on the end now. We're going to have a look in a little bit. We're actually not going to need to worry too much about the pi's there, but just to keep it mathematically correct, I will leave the pi with that because it's pi r squared. That's the radius squared. We'll stick pi with that. Now moving on to the shaded region. To get the area of a shaded region, we get the area of the bigger shape, which is the circle with the radius 2n plus 6, and we take away the area of the smaller shape, which is the circle with radius n minus 1. So we need to square both those radiuses, work out the area of both, and take them away from each other. So if we start with the big one to start with, so we'll go with the 2n plus 6. There we go, and we're going to square that. Now rather than writing out the double bracket here, I'm just going to square it from there. So 2n times 2n would give us 4n squared. Then we're going to have 2n times 6, which is 12n, and we've got two of those, so plus 24n. And then 6 times 6 will give us 36. And again, that is going to have pi with it, and that's the area of the large circle. Moving on to the little one, we've got n minus 1, and that's being squared. So n squared is going to be our starting piece there. Then we're going to have minus n, so minus 2n. And minus 1 times minus 1 gives us plus 1. And again, it's the area of that circle, so that's going to be stuck with pi as well. Now to get the area of the shaded region, we need to take these away from each other. So I'm going to do the one above, and I'm going to take away this one below. Rather than writing it out as a big long sum, because I've got a limited space, I'm just going to take them away from there and look at it piece by piece. So we've got 4n squared, take away that 1n squared there, and that leaves us with 3n squared. We've got 24n, we're going to take away negative 2n, so taking away a negative, that's going to add it on, so it's 24n plus 2n, so that's plus 26n. And then for our last piece there, we've got 36, and we're going to take away 1. And 36, take away 1, gives us positive 35. Right, there we go. So that is the area of our shaded region. Now coming back to the question, it said that that region there is greater than the area of the circle with radius n plus 13, which we've worked out just above. So what we've got is that this area here, which obviously also has pi with it, okay, because we haven't got rid of the pi yet, it says that that is going to be greater than the area that we have here. So the n squared, and again it is with pi, the n squared plus 26n plus 169. There we go, and that's with pi. Now because we've got pi on both sides, we can just divide both sides by pi, so actually we can just get rid of these pi's, we can just get rid of those. There we go, and we can start working on solving this. Right, so I'm going to get rid of some more working out here because we're just going to have a look at this last line that I've drawn. So if we get rid of all of this, we'll get rid of the area of that, we'll get rid of these, there we go, and we'll just have a look at what we've created here. Okay. So we've got our inequality. Now what we can start to do, and we can kind of forget that those brackets are there now that we've got rid of the pi's, so rather than rewriting it, let's just get rid of that. There we go. And let's start moving everything to one side. So first of all, I'm going to minus this n squared from both sides. So minusing that from 3n squared gives me 2n squared. I'm going to take away this 26n from both sides. So take that away from 26n. That's going to disappear, so that's gone. And I'm going to take away this 169 from both sides as well. So I need to take that away from 35, and 35 take away 169, where you can just do 169 take away 35, and it leaves you with minus 134. There we go, so 169 take away 35 is 134. So obviously doing that the other way around gives us minus 134, and that is now greater than 0. Obviously you can take that step by step. I've just sort of moved them all in one go. So obviously both these numbers are even, so we can divide both sides by 2 now, just to simplify this a little bit. And if we divide both sides by 2, we get n squared minus, and we need to do 134 divided by 2, and that is 67. So n squared minus 67 is greater than 0. Okay, so obviously we can actually think about which number here is going to be bigger than 0. Now it might be a little bit clearer if I move the 67 to the other side. We can't factorise this, okay, but what I can do is I can just add that 67 back over to the other side, and we'll have a look at what number we can get here. So we've got n squared has got to be bigger than 67, okay. Now this is our key piece of information. Now we know that this number squared has to be bigger than 67. Now if we think about some of the square numbers, we could have 8 squared, which is 64. Now 8 squared is not bigger than 67, so that's not going to work. 9 squared is 81, there we go, and that is bigger than 67. So obviously, as it says in the question, I'll just highlight this, look, it says n, a number for n has to be a whole number, it has to be an integer, so 8 is out of the question, it's not bigger than 67. But our next whole number up 9 is bigger than 67. So the smallest or the least possible value that n can be equal to 9. There we go, and that is the first number that we can sub in that gives us a value there that's bigger than 67. So there we go, that's our final answer. N equals 9, that's the least possible value that n can be to make sure that it's bigger than 67 there, and obviously satisfies this inequality that we've written earlier in the question. Right, there we go, that was quite a tricky one. Okay, but that is the end of that question. Let's have a look at our next one. Okay, so this question says n is an integer such that 3n plus 2 is less than or equal to 14, and then we've got this fraction here, 6n over n squared plus 5 has to be greater than 1, and it says find all the possible values of n. Now to start with, there's quite an easy element to this, and that's solving this inequality here. That's just a nice little linear inequality. So if we minus 2 from both sides, we get 3n is less than or equal to 12, divided by 3, we get n has to be less than or equal to 4. Okay, so that's part of our solution there. We know that this number that we're looking for, these values of n, have to be less than or equal to 4. Now what we need to do is have a look at that second one. Now the second one's a little bit more complicated, but it's nothing too bad there. All we have to do is multiply that n squared plus 5 over to the other side, obviously to eliminate our fraction here, so we can go about solving it. So if we do so, let's just write that in. We're going to times by, I'm going to put it in a bracket, n squared plus 5. Now because it's 1 on the other side, I don't need to worry about it being in a bracket. If it was a different number there, then we would have to expand that out. But as it's a 1, we just end up with 6n has to be greater than n squared plus 5. Right, okay, so let's make it 0. Now rather than having a negative n squared, I'm going to move the 6n to the other side. And again, just to keep it in that quadratic format, I'm going to slot it in just here after the n squared. So we have 0. Is greater than n squared minus 6n, as we're taking it away from both sides, add 5. There we go, and that's our inequality there. Now we can actually switch this over a little bit. Obviously, if we normally want the inequality over on the other side there, so we can just think about whether it's less than or bigger than 0. And when you move an inequality, we just need to swap the symbol over, so we can rewrite this. We can write n squared minus 6n plus 5 is less than 0. Again, I go into that in the video on quadratic inequalities, but if you think about it, think about a little basic one, like with numbers. If we've got 2 is bigger than 1, if we want to swap the numbers over, so 1 and 2, we would have to say 1 is less than 2. So our inequality swaps over there if we move things to the other side of the inequality. So just a little bit of an explanation now as to how we flip that sign over. Now we can actually go about factorising this. So for 5, the only options are 1 and 5. So in our brackets, and it's negative 6 in the middle, we're going to have n minus 5 and n minus 1. that's less than 0. So there we go, our two solutions, we get n equals 5 and n equals 1. So again, thinking about this in terms of a quadratic, okay, in terms of our curve, we've got 1 and 5, both positive, and we are looking at the numbers less than 0. So we're looking at this little bit here. So to write that, we would write it obviously like we have done in a previous question, with our arrows pointing to the left, our smaller number on the left, 1, and our bigger number on the right, 5. There we go. So that's our second inequality there. So we've got 2 now. We've got n has got to be less than or equal to 4, and n has to be between 1 and 5. That is not including 1 and 5 though. So if you think about the numbers that are between 1 and 5, not including 1 and 5, we've got 2, 3, and 4. And obviously, having a look at our other inequality there, n has got to be less than or equal to 4, and all of these three numbers are less than or equal to 4. So all the possible values of n are 2, 3, and 4. And there we go. And there is our final answer for this question and our three possible values of n. Okay, obviously it does say in the question n is an integer, so we can't have any decimals or any sub numbers in between these. It's just 2, 3, and 4, and that is our final answer. Right, okay, let's have a look at our next question. Okay, now personally I think this is probably one of the hardest out of the bunch here, okay, because we're going to have to apply a little different bit of maths here. It says the diagram shows a parallelogram and the area of the parallelogram is greater than 15. Okay, show that 2x squared minus 21x plus 40 is less than 0, and hence find the range of possible values of x. This is quite nice actually, because it says show that this equals less than 0, and then it says find the range of possible values of x. In an exam scenario, you know, if we didn't manage to show that it was 2x squared minus 21x plus 40, we could still go about factorising and solving that to find the range of possible values. Okay, but we are actually going to go about showing it. Let's have a look at how we do that. Now the area of a parallelogram is the base times the height. Now unfortunately this length here, this 10 minus x, is not the height, it's the horizontal length there, so we don't have the height, so we can't just do a nice simple multiplication there. We're going to have to think about another process. Now what we do have is an angle, okay, and when it comes to a parallelogram, okay, this is one of those quite nasty questions here, because if we split the parallelogram up, look, we can turn it into two triangles, and those two triangles have equal area. So what we can do in order to work out the area of a triangle is use trigonometry. You can use half AB sine C, okay, for the area of a triangle. So this is why I think this is probably one of those harder questions, because not only did you have to kind of think outside the box a bit by splitting this up, you've then got to also apply a bit of trigonometry. So for our formula we're going to use the area equals half AB sine C. Okay, so our C is the angle in the question there, and our A and our B are the two adjacent sides to that. And there we go, so we've got A and B in any particular order there. So if we start plugging these pieces into our half AB sine C, we should be able to get the area. Now remember as well, it says in the question that the area is greater than 15, so we are going to make our quadratic, well, not necessarily a quadratic, but we're going to make our inequality there as we get there, and it is going to be a quadratic, as we've got some, you know, double brackets to expand here. So we've got half AB sine C, so we're going to do a half multiplied by, and we've got A, which is 2x minus 1, B, which is 10 minus x, okay, and then we've got sine C, there you go, and C is 150. And if I put this all in one go, I could now say it's greater than 15, but obviously what I'm working out now is only the area of this one triangle here. So as I know that eventually I'm going to have to double that to get the total area, what I could do, rather than obviously saying it's greater than 15 and trying to work it out that way, I could actually just put times 2 in here, okay, and just obviously times that by 2 from the start. So let's just simplify that a little bit, and then we'll set it greater than 15. Right, so one little thing that stands out to me at this point is we have a half up here, and we've got a times 2 at the end, obviously, because we've got 2 of them. And a half times 2 is just 1, so that's actually just going to eliminate that, so we can actually just get rid of that straight away. Okay, so actually looking at this, what we've actually got, as they're going to cancel out, let's just cross them out here, look, they're going to cancel out. We've actually just got that double bracket now to expand. Now one other thing is we do have this sine 150 here. Now with sine 150, that is one of the nice exact trigonometric values to actually have a look at. Now it's actually, if you think about the supplementary angles, and I've mentioned this in a previous video, if we have sine 150, which is not you know, as commonly known, or one that's nice to work out, these angles here, if you find the other one that makes it add up to 180, so sine 30 would make it add up to 180, those two exact values are the same, okay, if the two values add up to 180. Just like sine 140 is the same as sine 40, and again sine 100 is the same as sine 80, and you can check that out on your calculator if you've not seen that before, but it gives us a nice way of actually finding that value of sine there, okay, particularly when these sorts of questions come up as non-calculator, but I'd just like to talk about this anyway. And sine 30 is one we should know. Sine 30 is a half. There we go. So sine 150 is also a half. There we go. Now I'm going to move that out of the way because that was just a bit of a sidetrack there, but they are some of the values that we're going to use. So we're going to use the value of sine 30, or the value of sine 150, which is 1/2. There we go. So let's just expand this double bracket. Done a lot of simplification there before we've actually done any sort of expanding. All we've done is sub it in and get rid of a few bits now. So let's start by expanding this. So 2x times 10 gives us 20x. We've got 2x times the minus x, which is minus 2x squared. Then we've got the negative 1 times 10, which is negative 10. And negative 1 times the negative x, which is plus x. There we go. And if we simplify that down, and I'm going to put the x squared at the start, so we've got a minus 2x squared. We have got the 20x, add the 1x, so that makes 21x, so plus 21x. And then we've got the minus 10. And that is all getting times by a half, so let's just close the brackets there. I'll put the half at the end. I'd rather put it at the start actually, but I've run out of space there, so we'll put the half at the end, and it says that that is greater than 15. There we go. So we're at this point now, and preferably before we move on, there are two things we could do here. Either we can times this whole bracket by a half, okay, which I would say if they were all even would be quite nice, but as we've got that 21x there, I'd rather not be halving 21 and having decimals in here. So rather than doing that, I'm just going to times both sides by 2. Okay, obviously a half times 2, we already know from earlier on, makes 1. So that's just going to get rid of the half, and it's just going to make this 1530 instead. So we'll do that. Let's have a look. We get minus 2x squared plus 21x minus 10 is greater than 30. There we go. Right, so in order to actually solve this, let's just get everything onto the other side. Let's make that negative 2x squared positive, just to avoid having to try and factorise with that. So if we move everything over, we're going to want 0 on the left, and that's going to be greater than now positive 2x squared. And again, I'm just going to slot all the pieces in front, just like we have done in previous questions. I'm going to minus the 21x over. There we go, so we'll minus this piece over. So minus 21x. Again, you can take this in lots of steps if you want. It's just quite nice just to save a bit of time and not do that. And then we can add the 10 over, and we're adding it over to the 30, so that'll become plus 40. There we go. So that is our quadratic inequality there that we need to solve, okay? But obviously looking at the question, it did say show that, and actually I completely forgot it said show that while I was doing it. I got a bit carried away. It says show that 2x squared minus 21x plus 40 is less than 0. So obviously remembering what we said on one of the previous questions, we can swap this symbol over to the other side. Let's get rid of that, let's not confuse that with equal to as well. So we can just swap that over, so we can say 2x squared minus 21x plus 40 is less than 0. And there we go, that's showed that for us. Now for the next bit, it says hence find the range of possible values of x. So we'll treat that as a separate part of this question. So we'll get rid of all this working out now, and we'll start to have a look at that second part there. Let's get rid of all of this. Might take a little while to actually get rid of all that. There we go. Right. So that's our inequality, our quadratic inequality that we're going to solve. So if we move that, and now we'll just look at the actual solving part. Okay, so factors are 40. We can't simplify all of this, unfortunately, as that 21 there, that only divides by 3 and 7, or obviously 1 and 21, and 40 and 2 don't divide by either of those. So 40, our factors we can have are 1 and 40, we can have 2 and 20, we could have 4 and 10, we could have 5 and 8. There we go. Right, so let's have a look. We've got a 2x squared, so we're going to have a 2x and an x. Okay, that's less than 0. And we want to make 21 in the middle, but one of them's going to double. So 1 and 40, let's think about that, and we'll start process of elimination. 1 and 40, we're never going to make 21 out of those. 2 and 20, with one of them doubled, 2 could double to 4, but that makes 24, so that's no good. 4 and 10, we could have 8 and 10, which is 18, or we could have 20 and 4, that doesn't work either. And it always ends up being the last one. So 2 times 8 is 16, and the 5 makes 21. There we go, so it's 5 and 8, and we want the 8 to double, and that's going to allow us to have 16. Now we want to have negative in the middle, but it's positive at the end, so they both have to be negative. So we want minus 8 over here, that allows that to double to make the 16, and minus 5 over here, and that's going to allow us to have that 21 there. Okay, so our two solutions, we get x is equal to 5 over 2, and x is equal to 8. There you go, just remembering there that 8 is our larger number. Now again, this inequality says less than 0, so thinking about our quadratic again, both positive solutions, and we are looking at the bit less than x, so sorry, less than 0, so less than the x-axis there. So it is a range of values, and it does say a range of possible values there as well. So we've got x in the middle, our arrows to the left, and we have our bigger number on the right, 8, and our smaller number on the left, 5 over 2. You could write that as 2.5 if you want as well. But there we go, that is our possible range of values. X can be anything between 2.5 and 8. And that's fine to leave as a fraction or as a decimal. And there we go, and there's our final answer. Right, okay, there we go. That was quite a tricky one. Well done if you are okay with that one, because that is probably the hardest out of the bunch there, maybe. You might disagree after seeing obviously some of the others, but I think that was probably one of the hardest one there, just as it had this involvement of half AB sine C as well. Made that question quite nasty actually. But there we go, let's have a look at our next one. Okay, so we're on to our second to last question. And it says here is a rectangle and a triangle. It says all measurements are in centimetres. And it says the area of the rectangle is greater than the area of the triangle. Find the possible sets of values of x. There we go, there's our hint again, look. The area of the rectangle is greater than the area of the triangle. So we need to find the area of the rectangle, so we've got to form an expression for that. So obviously for getting the area of a rectangle is just length times width, so we have a double bracket to do there. So we have x minus 1 multiplied by 3x minus 2, and that will give us the area of the rectangle. Now it says that that is greater than the area of the triangle. So to get the area of a triangle, we do half base times height, or base times height divided by 2. Now if we look at that, then let's just write it out as base times height divided by 2. Let's see what we get for that. I'm just trying to think, there is probably a nicer way of doing it, but it requires just sort of looking at this as the base rather than x as the base. Okay, so obviously if I do this to the side, look, we've got 2x times x all over 2, which is 2x squared over 2. And then we have to simplify that. Top and bottom divides by 2, and we just get x squared. But obviously if we just halve the base, it's just x times x, and we could just write that out as x squared. Okay, obviously I'm just thinking, instead of actually doing all of this process with a fraction, we could just halve the 2x, and instead it's just x times x, there we go, which is x squared. Okay, just a little bit of a way of just saving a little bit of time when you're working out the area of a triangle there. Obviously just halving the vertical height there rather than the base. Okay, but there we go. We've got our quadratic inequality set up now. This is going to be quite a nice one by the looks of it. And now we just need to expand this double bracket. So x times the 3x is 3x squared. X times the minus 2 is minus 2x. Minus 1 times the 3x is minus 3x. And then minus 1 times minus 2 is plus 2. Let's tidy that up. So 3x squared minus 5x, when we collect those together, plus 2, and that is greater than x squared. There we go. That was the first time in a while that I've actually written out those middle two pieces there. I normally just sort of skip that step. So there we go. Let's actually make 0 on the right hand side of the inequality now. So let's minus x squared from both sides. So we'll get 2x squared instead. Minus 5x plus 2 is greater than 0. Right, okay, so we just need to factorise this. It's going to be a nice quick solution, this one. So we've got 1 and 2 that we can have. There we are. We want to make 5 in the middle, so we want to double the 2. So we've got 2x in a bracket, as we've got a 2x squared, and we've got x in our other one. This is all greater than 0. And we want the 2 to double, so 2 in the right bracket, 1 on the left, and we want them both to be negative, as we've got a positive 2 at the end there, and we're trying to make negative 5, so we've got negative 4 and negative 1, and that makes negative 5 in the middle. So our solution on the left bracket there, we've got x is equal to positive 1 over 2, or a half, and we've also got x is equal to 2. And again, this is actually greater than 0 this time, so this is actually a little bit different to some of our previous ones. So let's get rid of this working out on the left here, just so we can draw out this quadratic and sketch that. And get rid of this working. There we go. Right, so if we've got our quadratic here, we've got two positive solutions. We've got a half and we've got 2. Obviously not drawn to scale there. And this time it says greater than 0. So greater than 0, we're going to be looking at this part and we're going to be looking at this part here. So obviously if you do draw a little sketch of this, which I always recommend, you've got a half and you've got 2. So we've got one solution on the left there, where we've got x has got to be less than a half. And we've got one on the right here where x has got to be greater than 2. So there are possible values of x. Now, this is obviously related to shape and not just a number, not just an equation. So if we actually look at this, there is something wrong with our solutions. We can't give both of these as a possible set of values because anything less than a half, following this one on the left here, is not going to work. You know, just looking at one of them, it's not going to work in the width of our rectangle there. We can't have anything less than a half because otherwise the width of our rectangle would be less than 0 and we can't have a negative length. So that one there, the x is less than a half, is not going to work in terms of our solution, which means our values have to be bigger than 2. Okay, so we only have one set of possible values for this one here, and it's that one on the right there. So x has got to be bigger than 2. Okay, right, so there we go, something a little bit different at the end there, having to actually apply that to the shape and have a think about obviously something that makes sense and something that works within the question, and actually spotting that x cannot be less than a half, as this would give us a negative length. Just having a look at the other two, it works on both lengths of the triangle, and it actually doesn't work on the length of the rectangle either, does it? Because we've got 3x minus 2 there. 3 times a half is 1.5. Take away 2 is negative a half. So yeah, it doesn't work within the rectangle at all. But there we go. That's our solution for that one. X has got to be bigger than 2. And we're going to have a look at our last question now. And here it is. Right, okay, so on to our last question. Now this says the figure shows a plan of a garden and the marked angles are right angles and the 6 edges are straight lines, and it says the length shown in the diagram are given in metres. It says the area of the garden is less than 120 metres squared. Find the set of possible values of x. Now this is quite a tricky question, okay, and I'll explain a little bit more about that at the end, but we do have to think about working out the area here, so we need to split this shape up. Now it doesn't matter which way you split the shape, I'm just going to opt to split it this way. Okay, but we need to work out the two separate areas as with any compound shape. So I'm going to label this the area of 1 and the area of 2, and we'll work out an expression for both of them. Now for the area of 1, that's quite nice. We've got the two side lengths there. We've got the 2x plus 1 and the 2x. So we can times those two together. So we have 2x multiplied by 2x plus 1. And if we just expand that straight away, we get 4x squared plus 2x. Moving on to the area of the rectangle number 2, we need to just have a little bit of a think because we've got 4x here, but obviously this is 2x there, so it's halfway, so this is also 2x. So we're going to do 2x and times it by the 6x plus 3. So we have 2x and we're going to multiply that by 6x plus 3, and that equals 12x squared plus 6x. There we go, and if we add those two together, that gives us our combined area. So add those two up, we have 16x squared, add 8x. There we go, and it says in the question, the area of the garden is less than 120. So we can say that that total area there is less than 120. And obviously we want 0 on the right hand side there, so we'll move that 120 to the left. So if we do that, we get 16x squared plus 8x minus 120 is less than 0. Right, okay, so we want to think about how we can simplify this. Now let's just have a think. 8 is our smallest number there, 16 divides by 8, and 120 divides by 8 as well. It divides to make 15. So let's divide everything by 8. So let's write that down. Here we go, let's divide by 8 just to simplify it. And we get 2x squared plus x minus 15 is less than 0. There we go. Now I want to think about obviously factorising this now to get our two solutions. So if we factorise this, we can have 1 and 15, or we can have 3 and 5. Now I'm going to get rid of some of this working out, so we've got a bit more space. Let's get rid of these areas. There we go. And just stick with what we've got there. Right, there we go. So factorising this then, we're going to have a 2x in one of the brackets and an x in the other bracket. There we are, and this is going to be less than 0. So to make 1, we could have 6 and 5s, because one of them's going to double, so we want the 3 to double, and 5 over here. And we want positive x, so we want positive 6, take away the 5. There we go. So we get our two solutions there. For the first bracket, we get x is equal to 5 over 2, positive 5 over 2. And on the right here, we get x is equal to negative 3. Right, there we go. So putting this then into an inequality, it's less than 0. So again, obviously thinking about our quadratic curve, we've got negative 3 and 2.5 there, and we are looking at the bit that is less than 0. There we go, so below the x-axis. So that is going to go into a joint inequality. Let's have a look then. So let's put that in. So we've got x in the middle, both pointing left, smaller number on the left, negative 3, bigger number on the right, 5 over 2, or we could put 2.5 there, and there we go. That is our set of values that we can have here. And just highlight that off as our answer. Now, thinking about the logics of this question here, obviously there are some values within that range that we can't have, as these are all lengths here. So looking at, obviously we've got 2x, we've got 4x, we've got 2x plus 1, and we've got 6x plus 3. None of these values can be negative, okay? Obviously if the answer was negative 2 or something like that, then this length over here would be minus 4, and we can't have a negative length. So the smallest value that we can actually have is, well, anything bigger than 0. So actually looking at our inequality here, we actually can't have the minus 3 over there, okay? We can't have any of these negative values. It has to be bigger than 0. So we're going to have to write this in a slightly different way, because none of those values less than 0 are going to be allowed. So to make this actually complete and correct and finished, we're going to have to edit that slightly, and we're going to have 0 on the end, so anything bigger than 0, there we go, and then anything less than 2.5 like we had originally. Okay, so obviously thinking about the logics there, we had a look at a question similar to this previously, where we couldn't have a negative length, and this one here just required us just to think logically about these negative numbers here, obviously making sure that we didn't have any negative lengths there. So our final answer, as an inequality was this one here, but in terms of the actual question, the set of possible values of x that we can actually have in this particular question, it's got to be between 0 and 2.5, and that's obviously not including 0, because we can't have a 0 length either as well. That doesn't exist either. So there we go, that's our final answer, anything between 0 and 2.5, and that is the end of our last question. Now, a little bit of a confession here, this question is actually an A-level question, so if you did manage to get that and you did manage to figure that one out, then well done, because this is actually, you know, much harder than not necessarily much harder than a GCSE question, as this is something which could potentially come up, but this was actually an A-level question here, so well done if you did manage to get that. But obviously it's something which could come up in a GCSE here, and there's nothing out of the GCSE spec in this particular question. But there we go, hopefully you found that useful and helpful. If you did, please like, please comment, please subscribe, and I'll see you for the next one.